Whenever we talk about the search for life in the universe, and especially intelligent life, the Drake equation inevitably comes up. This famous mathematical formula, first presented in 1961 by radio astronomer Frank Drake, seeks to estimate the number of intelligent civilizations currently capable of communicating in our galaxy. Although the equation is now more than 60 years old, it continues to be a fundamental reference point for anyone involved in astrobiology and SETI, search for extraterrestrial intelligence. Even if many of you are already familiar with the Drake equation and may have even tried to manipulate its factors to estimate the number of intelligent civilizations, I encourage you to stay with us. In this video, we will delve deeper into the subject, highlighting some aspects that are often overlooked or misunderstood. The history of the Drake equation begins in the 1960s when Frank Drake, then a young radio astronomer at the Green Bank Observatory, was inspired by an article by Giuseppe Cocconi and Philip Morrison. These scholars had hypothesized that it would be possible to detect radio signals from intelligent civilizations on other planets in our galaxy. Fascinated by the idea, Drake decided to use the radio telescope to search for such signals. Although the search did not yield concrete results, the experiment led Drake to convene a historic meeting in 1961, attended by scholars from various disciplines, including the famous Carl Sagan. It was during this meeting that Drake wrote on a blackboard the formula that would later become known as the Drake equation. It is worth clarifying that the Drake equation is not a true equation in the mathematical sense of the term. Rather, it is a probabilistic formula, a model that seeks to estimate the number of communicative civilizations in our galaxy, based on a series of factors, many of which are still unknown. Although in recent decades we have made significant progress in understanding some of these factors, such as the number of potentially habitable planets, many uncertainties remain. For example, we now know that there may be about 40 billion potentially habitable planets in our galaxy, perhaps around 10 billion if we consider only those orbiting stars similar to the Sun. However, the presence of habitable conditions does not guarantee that life has indeed developed on these planets, much less that this life has given rise to technologically advanced intelligence. The Drake equation, after considering astrophysical factors, enters the domain of biology and technology. How many of the potentially habitable planets have actually seen the emergence of life? And of these, how many have developed an intelligent species? And finally, how many of these species have produced technology capable of leaving observable traces, such as radio signals or other forms of technosignatures? Technosignatures include any technological trace that can be detected over long distances. When Drake formulated his equation, he was thinking of radio waves, but today we consider a broader range of possibilities. However, even with the most optimistic assumptions, the number of technological civilizations in our galaxy could be much lower than hoped. Another crucial factor is time. Our civilization has been visible in space for only about 100 years, that is, since we started transmitting radio waves. If we consider that the average lifespan of a technological civilization might be 1,000 years, and compare this period with the age of the galaxy, about 10 billion years, we realize that the chances of intercepting a contemporary civilization are extremely low. To increase the chances of detecting other civilizations, we can hope that their technosignatures last much longer than the civilization itself, or that technological civilizations emerge all in a relatively close era to our own. However, these remain conjectures. Finally, a rarely discussed aspect of the Drake equation concerns the spatial distribution of civilizations. Even if the equation told us that there are 2,000 technological civilizations in our galaxy, the average distance between them would be about 1,100 light-years. A distance that makes any form of practical interstellar communication impossible, not only because of the extremely long response times but also due to the enormous power required to transmit signals that can be detected at such a distance. In conclusion, despite the low probability of success, the search for signals of intelligent life must continue. As Cocconi and Morrison said in their 1959 article, the probability of detecting a signal is difficult to estimate, but if we don't even try, we are sure that the chances are zero. Thank you for watching, leave a like, and subscribe to the channel to support us.